Hey guys, on chapter 6, section 2, example number 4, we are determining whether or not these two matrices are inverses of one another. Before we do anything, what you do need to understand is in order to determine if something is an inverse, you end up with an identity. Very similar. I'm going to do a little bit of review. It's not necessary to write this down, but just to explain. If I am trying to determine what the opposite of 3 is, I need to make sure that I get the additive identity, which is 0. So this is kind of where the identity goes. And this is where you have your value and then the opposite. And in order to get the additive identity of 0, you would have a -3 because 3 and -3 give me the additive identity of 0. Similarly, if I'm solving for the reciprocal, okay, then I would say that would be 3 times what is the reciprocal of 3, which would give me the multiplicative identity of 1. So 3 times 1/3 gives me 1, therefore 1/3 is the reciprocal, okay? All right, so now that this is kind of something that you can see that you've done in math for a little bit, we're talking about trying to determine the inverse matrix. So what you need to do is figure out what the identity is for matrices. This is called the additive identity because that's what it is that adds whenever you add a number and its opposite together. This is the multiplicative, which is just the fancy way of saying multiplication. But that's the multiplicative identity. Anyway, these are the different things that, that you have already learned. In order to determine what your inverse matrix or your identity matrix is, I'm going to write it up here. You have a diagonal of 1s, okay? And it goes from the top left to the bottom right. And so if you had a 3 by 3, then reading across, it would be 1, 0, 0, 0, 1, 0, 0, 0, 1, okay? So it's just a diagonal of 1s where everything else is 0. So in order to determine if these are matrices, and I do expect you to use your calculator on this, you're going to put in matrix A times matrix B. So you would go into your calculator and you would put -3 to -2, 1 times matrix B, which is 1, -2 to -3. To remind you how to do that, you would go to your matrix button, which is actually located the 4th button down on the left. You're going to go over to edit and you would enter in a 2 by 2 matrix A and a 2 by 2 matrix B. Then you go back to your main screen and you name matrix A, and then you put in times matrix B. You actually don't even have to put in the multiplication sign. You can just put those in one by one. And then when you do, you get the identity matrix, which is 1, 0, 0, 1. But because we know multiplication is not necessarily commutative for these problems, you do have to check it both ways. So I've got to come back and check to see if B times A gives me the same identity matrix. So then I don't have to put anything different into my calculator. I just have to multiply it in the opposite direction. So I would say matrix B. So I'm going down to matrix B times matrix A. And when I multiply those, so in all honesty, what I am doing is 1, -2 to -3 times -3, 2, -2, 1. And this also gives me the identity matrix, okay? So since they both give me identity matrices, then I can verify that, yes, these are inverses. Matrix A and matrix B are inverses. And that is your answer for this problem.